Right, hello ladies and gentlemen, and welcome to today's video. And today we are going to start having a look into the old PlayStation 4 Controller Sync issues when the issue is actually caused by firmware corruption as opposed to physical failure of the Bluetooth wireless card. Now, we do already have a video, and I'll link it just up here. For that issue, we've already covered this once, albeit a slightly different flavour. So as I say, that is the controller sync issue when it's caused by a failure of the actual Bluetooth and wireless module. And in that particular video, we swapped the module out for a replacement, and everything works nicely again. Now that does happen quite a bit, but occasionally you do get it where the issue is down to a failure of the onboard flash, or the software, the firmware should I say, on board the onboard flash, as opposed to any sort of physical hardware defect. So today we're going to start having a look into that particular issue, and this has been one that I've been meaning to do for a while, but just, excuse me, haven't got around to doing it. So that is what we're going to start having a look at today. Now what we're going to do is we're going to break this down into three parts. So we're going to do part 1 today, part 2 a little bit later on in the week, and part 3 probably a little bit later again. The reason for that is because, you know, doing this is probably going to take a couple of hours all told in footage, and while I don't mind doing long videos and I actually quite enjoy it, I also enjoy watching quite long videos as well when they're teaching me something, but I appreciate that a lot of people don't. Because they simply don't have the time, or because, you know, they've got things they'd rather be doing. So that's absolutely fine, and consequently, rather than just making this into one big mammoth video, I thought I'd break it down into a couple of component parts. So we're going to do this in 3 parts. The other reason I'm going to do that, I'm going to do this way with this particular video, is that on other videos that we've got on this channel, which are a couple of hours long, what tends to happen is people don't watch the whole thing. They just watch the bits and pieces that they like. And whilst that's not recommended for tutorial videos, because you never know what you're going to miss, what tends to happen is that people don't watch it and then ask questions that are actually answered in the video. So I figured if we can break this down into smaller parts, then there's less chance of that happening. So that's what we're going to do. So I'm just on my lunch hour here at work. So we're going to go through this particular first bit here. So hence the table, and I'm not sure the lighting's that great in here, but it's going to have to do for today. So what we're going to do is, as I say, we're going to break this down into 3 parts. So first part today, we're going to look at the hardware required for this repair. Now we are going to have to build a flash programmer, and we're going to use this to actually dump our existing firmware, and we're also going to use this to reprogram our fixed corrected firmware dump back to our onboard flash before we actually resolder it and reattach it to the PlayStation. So we're going to go through the equipment, because chances are you're not going to have this equipment kicking around. Like I say, you know, I do a lot of fiddling with this sort of stuff. I didn't have it, I had to go order it. So unless you're sort of like, you know, Bill Gates style nerd, you probably aren't going to have this kit. So we'll include in the description all the links and stuff, and the sites that you can find it. So we're going to give like UK based sites. I'm sure that some of these sites can ship worldwide, and you'll be able to find these parts of the world over fairly easily. They're not anything exotic, they're fairly straightforward things to find. So push comes to shove, eBay, Alibaba shouldn't be a problem really for you. So that's what we're going to do. So today we're going to take a look in this first part at the hardware required to build the programmer. So this is to build the programmer. Now it's important before we do get started on what's in these boxes that we actually are aware of what we're letting ourselves in for this particular repair. Now this particular repair is not easy. The issue is down to firmware corruption, and anybody who knows anything about computers at all will know that firmware is very important stuff and actually enables things to work in the way that they do. Corrupt firmware, as I'm sure that even the most sort of technically novice amongst us probably aware, messing with firmware is not particularly desirable, and it isn't something you want to enter into lightly. And rather like Windows registry on your PC, fiddling with it and doing things incorrectly can cause all sorts of mayhem and even include your console completely useless. And bearing in mind the information on this chip is per box, you have things on this flash ROM that we are going to be manipulating which are unique to your PlayStation the world over. And consequently there isn't another one like it anywhere else in the world. If we corrupt this or we mess it up and we knacker it, we ain't getting your PlayStation back. So it's important to be aware that you are fully aware of what you're letting yourself in for during this repair, and that you take things incredibly slowly. You follow everything I tell you by the letter. You watch these videos in their entirety several times over before you try to do this to your own machine, because otherwise, well, there might be tears. So with that said, let's get on to the stuff that we're going to actually need. So there's a few bits and pieces. Firstly, your PlayStation, obviously. You are going to need, let's get the boring stuff out of the way first. You're going to need you're going to need a mini USB lead. So that's not like the ones that you used to plug your DualShock 4s in. Those are micro USB. Mini USB are the slightly bigger ones, so the ones that you probably used to find on mobile phones sort of 5 or 6 years ago. In fact, if you've got a DualShock 3 and a PlayStation 3, it's the cable that you'd use to plug your DualShock 3 controller into your PlayStation 3. So it's the slightly older type of mini USB cable, if you like. So you're going to need one of those, just a straight through sort of standard USB on one end, and the mini USB at the other. So mini USB lead is what you're going to need. Now then, on to the other stuff in this box. So we're going to go through the bigger box first, because this is sort of like the really important bit. Now, I've already built this, so this is why it looks slightly odd. You are going to get this in component parts, unfortunately. So the green board there at the bottom, this bit here. This here is a Teensy 2.0++ development board. So this is what we actually use to do the programming of our flash ROM, and as you can see, there are lots and lots and lots of tiny holes around the edges of the development board, and they're all labelled up there. Look, if you can see F1, F2, F3, F4, F5, F6, and whatnot, and there's some C's at the bottom. There's a small button there on the bottom edge, which is used to reset the machine. The little processor chip there in the middle, which is underneath that QC pass sticker, and of course our mini USB socket there, which connects the development board onto our PC. And as I say, I've already built this, so you're going to need one of those. Now, to get one of those, you can get them all over the place. I actually bought this via eBay from a console mod store in France. As I say, they do have an eBay shop. It turned up here in the UK after about 3 or 4 days. So I was really pleased with that. Great supplier, really highly recommended. I'll pop the link to their web shop below where you can find these things. I think it turned out by the time I got it shipped here, it was about 18 to 20 quid, something like that. So not expensive, but it is essential. Okay, one more little job you've got to do is to actually make a small modification to the Teensy so that it provides the correct amount of voltage to your PS4 NOR flash chip. And for those who are a little more eagle-eyed, might have noticed that this tutorial has already appeared once over and disappeared again, and that's because I forgot something fairly fundamental. And it wouldn't have mattered as such, because you can power the NOR via 5 volts, although it's not recommended. It's actually a 3.3 volt NOR flash. So what we need to do is actually make a modification to the Teensy, as it provides 5 volts by default, to step that voltage down to 3.3 volts, so it's suitable for our NOR flash. So all we need to do, and to be honest, I'd recommend you do this before installing these GPIO pins, because it would make life a lot more simple, and that is to actually install a voltage regulator to the bottom of the Teensy. Now, the nice thing about the Teensy is that it already has the location for a little voltage regulator to go on there, so it supports this modification more or less out of the box without you having to do too much nastiness to it. So this is easy, and we're going to walk you through it. So actually what you need to do is you need to go, and you also need to purchase a 3.3 volt regulator. That's this little square black thing just there. if the autofocus will actually play nicely, because it's got my finger. There we go, that little black thing there just next to my thumb. That is our 3.3 volt voltage regulator. So what that's doing, that's taking the 5 volts from the USB, and it's actually stepping that down to 3.3 volts, and then it's actually passing that out through the rest of the circuit. So what you need to do is you need to go away and buy one of those. Now the part number that we've got here is an MCP1825. To give you the full part number, it's actually MCP1825S-3302E/dB. So if in doubt, just have a look in the description and you'll find it in there. They're a couple of quid. I got these from RS for £2.08. I could get them in the smallest quantity I could get them in was 5, so you'll have a few spare, which is always useful. And basically all you do is out of the box on the Teensy, you will notice that this area here is free. So you've got these 3 solder pads. You've got these little jumper locations here. You can see it says 3 volt, 5 volt there just next to my thumb. There's 3 little pads under there, and then there's the big ground plane there just underneath the USB. So actually what you need to do is you need to solder the 3.3 volt regulator into the position. So you can see there's a little white boundary around the edge there of the little IC. So you need to just install the 3.3 volt regulator there. So you solder the larger ground tab to the ground pad there just under the USB, and the 3 legs there to the appropriate places on the board, and it fits lovely. And then what you need to do is on the little jumper locations here, just by my thumb where it says 5 volts and 3 volts, there's actually 3 pads under there. And what you need to do, if we can get a decent focus on this, is actually between the 5 volts and 3 volts. So between that top pad there, you see the pad there that's empty by my thumb there, the top one. There's actually a small trace which runs between that and the middle pad. Now the middle pad and the bottom pad are actually shorted together, and I'll go through that in a second. But basically the small trace between the 5 volts and the middle pad needs to be cut. So you just use a Stanley blade or a sharp X-Acto knife or something like that, and just cut across that trace, and then just check continuity between that top empty pad there and the middle pad with a multimeter in continuity mode, or beep mode as some people might know it, and just make sure it doesn't beep or show any continuity. So it should read 1 for infinite resistance or open line on some meters, or OL as it would be displayed on some meters. If it does that, then you're good to go. And then, as I say, once you've actually got your voltage regulator installed and you've cut that little trace, you just need to bridge the bottom 3 volt pad with the centre pad, as we've done there with a little bit of solder. And what that will do is that will actually connect the output pin of this little regulator to the rest of the circuit. So rather than supplying 5 volts now, our Teensy is actually supplying 3.3 volts to our NOR chip at the other end of our jumper wires over here, which is exactly what we want. Which is perfect. So that's the little modification we need to make there, and that's what I forgot to do last time in this video. Now then, the other things you're going to need, you'll notice these wires I've got here, and these I've actually soldered in to the Teensy board. Those are actually hard soldered in. So these little ribbon cables here, as you can see, they are rainbow coloured. They're all uniquely coloured, which is useful for when you have to actually assemble this. And basically I'm going to give you a pin out so you can see what's what. But there's there's several ways of skinning a cat as far as building this thing goes. Now what you can do is you can use some sort of GPIO header pins, and getting some female GPIO pins and things like that, and just plugging them on. I didn't have the time to actually get that done. I needed to get this built fairly quickly. So actually what I did was I went to Maplin and bought these IPC wires here. So these are male to female. I'll pop the link for those down in the description. Hopefully I'll be able to find them online. But they're in the store. These come in a pack of 40, and basically they have a male pin on one side and they have the female connector on the other. Now these are actually the same sort of connectors that you'd find in a PC case, you know, where you plug all the power and reset hard disk like jobbies in onto your main board. Well, those are the same connectors. So if you've got an old PC chassis kicking around, I dare say you could cannibalise the wires, solder them onto the vias on the Teensy development board in the appropriate place, and you'd have yourself a nice cheap one. Now, as far as I know, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 pins. So, as I say, if you do get the ones from Maplin as I did, you're going to get a fair few spare, which is nice because you can either build yourself a couple of programmers, or you've got spares for if these things get knackered at any point. But, you know, like I say, they're nice because they've got unique colours. So each wire is a different colour, which makes wiring this thing up to the socket incredibly easy. But we'll go through that in a sec. So what I will do is, as I say, I will give you a nice pin-out diagram for actually soldering this up. This you'll be able to find that at the end of the video. So all you do is you just plonk them in there, solder them up, and there you are, and that's it. So they all sit very nicely there. The black one there on its own there is ground, the white one at the end there is power, and the other 7 are all signal, which will actually be used to transfer data to and from our socket and ultimately our flash ROM. So you are going to need Teensy 2.0++ programmer board. You're going to need some form of IPC GPIO cable header assembly thing there. So as I say, you can get the pins and solder them in and then use, you know, the female to female to actually link them together, which would be nice. But as I say, if you're not that bothered and you're only going to be using it for this particular purpose, and like I say, you know, the cables are nice and easy to find at Maplin. I think they cost about a £5 for the 40. Then why not do it that way? We're also then going to need one of these. So this is a SOIC 16 to DIP 16 300mm data socket. So let's have a look in here. I'm just going to open the box. So in here we've actually got this thing. And what this is essentially a 16-pin DIP 16 or SOIC 16 package programmer, basically. So what it does is traditionally you'd have a DIP 16 programmer. Those pins that all sit in there. The SOIC 16 package would go in there at the top, and you'd plug that in, and effectively it'd convert one to the other. So that's useful if you've got a programming board, but of course that's not what we're using this for. What we're actually using this for is, this is a nice socket. So our SOIC 16 package BIOS chip just goes in there, so you can see where each of the 16 legs will sit in underneath these contacts here. And essentially what we use is the pins underneath, which would normally go into a socket on a programming board, actually connect to our female end GPIO pins here. So we wire these up to some of these pins here, which does all the connection for the data, power and ground to our chip. Chip sits in there, and then basically the whole lot gets connected via that mini USB cable to our PC. And then that actually allows us to run the various commands from the PC to dump the firmware from the chip to our PC, so we can get it into a hex editor and manipulate it. So that's what we need to do. And so these are the various bits and pieces that you're going to need. Now these things can be found on eBay. This particular socket was in the UK from a supplier called datahardware.co.uk. I think it was about £8. If I remember rightly, you can find these on Alibaba for about £3 or £4. But of course, be prepared to wait for the shipping and things like that, because from China it could take a while. So I think it's about 3 to 4 weeks. This got to me within I think it was the next working day actually. So if you're stuck for time and you've got one you really need to get done, whether it be your own or somebody else's, and you push for time, then as I say, I really do highly recommend those guys. They were great. So this actually has a part number on the board underneath written CNV-SOP-DIP28. And as I say, this is actually a This is a SOIC 16 to DIP 16 package converter, and like I say, basically it's spring operated. So all you do is you push the clamp down, that opens the jaws. You just sit the BIOS chip in there, let go, and it actually clamps the legs down underneath these contacts. And then, like I say, our GPIO header pins actually take the data from these pins down into the Teensy board, and then via the mini USB lead that we have there into our PC. We're going to use SPI way to actually dump the firmware. So that is a superb piece of free application developed by Judges, I do believe, who I think the current version is on 0.3. 0.2 is the version that is used by the Acid Flash tool. Anybody who's done a bit of research on doing this might have come across the Acid Flash tool. That requires version 0.2 to do all the dumping and programming and things, but we're not going to do that. We're going to actually use version 0.3. We will use the Acid Flash tool if you've come across it. If not, don't worry, we're going to obviously broach that software. So if you've not heard of it before, don't panic. But if you have, we're not going to use that to do the dumping of the chip and the programming. We're going to use SPI way via command line. It's not difficult, it's quite easy. And as I say, I just prefer to use the latest version rather than sort of making do with the slightly older one, just because one particular tool prefers it. So that's what we're going to do. So those are the bits and pieces of hardware you're going to need. As I say, it's important to be aware that we're going to be messing with some serious stuff here. You are going to require to be required to desolder the flash ROM from your PlayStation 4 motherboard. That's not particularly easy. It can be done with a soldering iron and a pin. I used to do that in the PS2 days when desoldering the DVD-ROM drivers and things like that. You can do it. It's a bit of a pain in the arse. It's a lot easier if you do have an air wand or something like that, a proper PCB rework air wand, like the Quick 861DW that we use on this channel, just to pop it off there. As I say, you can do it with a soldering iron and a pin at a push and just pop each leg up in turn. But it's not ideal. So you are going to have to do some sort of minor PCB rework to actually get the chip off, and then obviously you need to resolder it back on at the end of the process. It is firmware, so it is very sensitive, and as I say, it is, it's unique to your particular PlayStation. There's no sort of being able to get a dump from somebody else and reprogram it if it goes wrong. You are on your own, very much so, if you actually get this wrong. So it's important you let yourself, you know what you're letting yourself in for this process. It's not easy. You are going to need these bits and pieces. The total lot altogether is about just over 30 quid for the Teensy board, the socket, and the sort of GPIO header cables, and a micro USB leads about £1 off eBay if you really need one, but you've probably got one kicking around there somewhere at home. But yeah, the other bits and pieces you are going to need. Like I said, if you aren't in a rush and you're willing to wait, a couple of weeks for bits and pieces to turn up from China and whatnot, you can probably build this thing for less than 25 quid. To get your actual PlayStation up and running again, if firmware's the issue, then yeah, it's a bit of a bargain, isn't it? So those are the bits and pieces you need. So that's it for today. Yeah, we're going to let you go away and get those bits and pieces ordered. In a couple of days, we'll come back, we'll assemble this, and we'll actually get some firmware chips dumped, and we can inspect the dump and we can see what's going on in there and why it's broken. So that's what we're going to do. And what I'll do now is at the end of here, I will pop you a schematic diagram in for how you can wire this up and where it all needs to be plugged into, so we can get it all nicely prepared. The next video, part 2, we're actually going to install our Teensy board. So what we're going to do is, at the moment, these things ship blank, so they're dumb as a doornail until you actually put some software on them. So we're going to go through where you can obtain that software and how to program this board. So we're going to do the driver installation, which if you're using a 64-bit version of Windows 7 and above can be a bit finicky because of the driver enforcement, but we'll go through that. Don't worry about it, it's fairly easy. So we'll go next part 2, we're going to go through how to install the drivers, the relevant software, where you can get it from, and then we're going to program our Teensy board so that we can actually do some firmware dumping. And then part 3, which might be later on this week, might be next, Part 3, we're actually going to go through dump the firmware. We're going to manipulate that firmware, we're going to correct the issue, we're going to program it back, we're going to reinstall the firmware chip to our PlayStation, and hopefully we're going to get some controller activity again. So that's it for now. And as I say, what we're going to do is we're just going to stick those wiring diagram schematics up for you. So just skip forward another couple of seconds if you want to see those. I'll see you on the next vid. So TTFN, thank you for watching, and here come those schematics.